back, True Seeker. I want to give you guys a quick lesson on how to use the Gematrinator calculator. If you don't understand the ciphers, you won't know what you're looking at. This person right here I can tell is new to the study because he writes tariff equals 33 in full and single reduction. And what he doesn't realize is that if a word doesn't have an S in it, it's always going to be the same in full and single reduction. So let's get rid of these other ciphers here. Let's just put up full and what Derek has called single reduction. Before Derek built this calculator, I always called this method the S exception because this cipher, single reduction, only has to do with words that have an S in it. So for example, the word the will be the same in both ciphers. Any word that does not have an S will be the same in these two ciphers. Let's just change it to these. Notice these is 21 in reduction and 30 in single reduction. The reason this is so is because S is a special letter. It's the 19th letter. S, using the ordinal method, let's bring up the ordinal method here. We'll just look at it this way. S is the 19th letter, right? In numerology, 19 is 1 plus 9 equals 10, and then 1 plus 0 equals 1. S is the only letter you have to add together twice to get to a single digit. So that's why Derek's called it the single reduction, because, you're only reducing S one time. If I built this calculator, I probably would have just called it the S exception because S is the only letter you have to reduce two times. You know what I mean? So that covers that part. Now let's just reload the calculator and look at the base ciphers. When I began this study, I only taught about these two methods, which are based on the alphabetic order with the rules of numerology. And it was easier to teach this skill back then because, we were just looking at two things. So the way this works is you just take the alphabetic order, T is the 20th letter, H is the 8th, E is the 5th, you add it together, English ordinal. The value is 33. The reduction method is the rules of numerology. So what happens here is instead of T being 20, it becomes 2 because 20 is 2 plus 0 equals 2. H is still 8, E is still 5. So the becomes 15. And with these two methods, they'll always break down to the same numerology value. 1 plus 5 is 6. 3 plus 3 is 6. This is true of any word. You can type in any word. It's always going to be that way for the breakdown. So, knowing that these methods break down to 6, if we add in the reverse ciphers, what we know automatically is that the numerology of those words is going to break down to 3. And the reason that's so is because for words, the word the breaks down to 6. 6 plus 3 is 9. So if you're following me, whatever the numerology is of the forward method, the numerology of the reverse method, when you add the two together, it's always going to equate to 9. So if we take, just E. E is 5. We know that in reverse, E is going to be a value that breaks down to 4 because 5 plus 4 is 9. Are you following me? We know that B is 2, right? So in reverse, the value is going to break down to 7 because 2 plus 7 is 9. Are you following what I'm saying? We know A is 1. So in reverse, it's going to break down to a value of 8 because 1 plus 8 is 9. Let me pull up the full calculator here and just notice. A. With the forwards methods, 1s. With the reverse methods, 26 and 8. 1 plus 8, 9. This is how it works. These are the rules of this system. Something else worth remembering. I and R are the only letters that have 9 values. I and R are the only letters that have 9 values forwards and backwards. If you can remember I and R, they're your 9 letters. And Maybe you're thinking, well, if you add them together, that doesn't equal 9, but it does. 9 plus 9 is 18. 1 plus 8 for 18 breaks down to 9. So I hope I'm not confusing you. I'm just trying to show you the rules of how these ciphers work. Okay? And the way to learn this system is there's a formula. I know that J is the 10th letter in the alphabetic order. So in ordinal, J is 10. In reduction, 1 plus 0 is 1. Now here's the formula to get to reverse. It's 27 minus the alphabetic order placement. So 27 minus 10 gives us 17. You know, I know that P is the 16th letter with the alphabetic order, which means 27 minus 16 is 11. You see? And again, when you add the forwards and backwards methods, it's always going to take you to a numerology of 9. 9 is the glue in numerology. So if you're understanding the base ciphers, here's some other things. Let's get rid of the reverse for a moment so we don't get confusing. There's the exception in reduction for S, which we covered, right? We covered the S exception. The other exceptions in reduction are for K and V. And what Derek's done with his calculator is he's created something called full reduction KV, single reduction KV. And K is the 11th letter. In numerology, you don't have to break down 11. It's the master number. You also don't have to break down 22. 22 is the master builder number. So the letter V in reduction becomes 4. But because V is also 22, V can be 22 in reduction. Just like it is 22 in ordinal, right? Same with K. K can be 2 in reduction, or if you recognize its master numerology, it can be 11. So if you take a word with a K, kick, kick is 16 in reduction, but if you observe the master numerology of K, it's 34. You understand? Let's do a word with a V. There's so many to choose from. We'll just go with vice. In reduction, vice is 21, but if you recognize V is 22, then vice becomes 39. And here, let me just choose a word such as Viking. Because maybe you're looking and saying, well, the ordinal is the same as those master ones. That's just because the other letters in the word were single digit. But notice, Viking in reduction is 36. If you observe the master numerology, which is 22 for V and K for 11, it becomes 63. And then if you just do the ordinal value, it's 72. And that's because of the N. The N's 14 in the English ordinal, where in these other methods it's getting broken down to 5. You see? Now understand these rules for the 11th letter, the 22nd letter, and the 19th. They're also observed for the reverse reduction methods. So, we have reverse full reduction. Now we have to go in reverse order. So, Z is 1 up to A is 26. In this method, let me think. E is the 22nd letter. So notice, E breaks down to 4 in full reduction, but if you observe the exceptions, E is also 22. 27 minus 5, E is the 5th letter, 22. So E can be 22 with the reverse exception. What becomes 11 is P. P is the 16th letter. 27 minus 16 is 11. So P breaks down to 2 in full reverse reduction. If you observe the master numerology, it's 11. And then the 19th letter in reverse is H. H is 8 with the alphabetic order. 27 minus 8 is 19. So these are the rules for the exceptions with the reduction methods. Now let's do this. Assuming you understand that part, I hope I explained it clearly enough. Let's look at the other ciphers. And I want to explain things you need to know. So we've covered all of these up here are the reductions with the exceptions. English ordinal, reverse ordinal, just as the alphabetic order forwards and reverse. Francis Bacon. Here's what you need to know about this cipher as well as Frank Baconus. These ciphers have a relationship. What makes these ciphers different is capitalizing. So I'm going to write this word here with no letters capitalized. Notice in ordinal, alphabet is 65, in Francis Bacon, 65, in Frank Baconus, 130. Now pay attention what happens when I capitalize the A. Alphabet becomes 91. The reason why is because you add 26 for each capital letter. In Francis Bacon, lowercase a through lowercase z is 1 through 26. Uppercase a through uppercase z is 27 through 52. So uppercase makes all the difference in Francis Bacon. You have to make sure the capital letters are where they should be if you're using this cipher, you know? Just like this person left this comment here, people leave comments all the time. They're like, oh, I noticed that this is the same in ordinal and Francis Bacon. I'm like, well, that's because they didn't capitalize any letters. What Frank Baconus is, you know how when you were in elementary school, you know, around the top of the room, you might see letters and numbers, and you'd see a capital letter and a lowercase letter, a capital A, a lowercase a, an uppercase B, a lowercase b. That's the way this cipher works. Capital A is 1. Notice lowercase a is 2. Capital B is 3. Lowercase b is 4. You see? What's really interesting about this cipher are a lot of things, such as baseball. You know, we know that's a huge number in baseball. 108 double stitches on a baseball. But it's only true if the word is lowercase. You see? Baseball. Cubs broke the 108-year curse just using the alphabetic order. Major League, 108. You know? So, that's Francis Bacon, that's Frank Baconus. They are capital letter related. So if your capital letters are not in the right place, I mean, if you type fast like me, if you guys watch me decode, I'll often not take my finger off the caps lock fast enough when I'm typing, and I'll put an accidental capital letter in there. If you do that and look at your Frank Baconus value, it's going to screw it up. Like the word C shouldn't equal 77 in Francis Bacon. It should be 51. Unless you were looking at like a billboard decoding and, you know, it was all in caps, then it might be interesting that way. But I'm just like, you know, you have to be specific with the capital letters with Francis Bacon. What English Extended is another Gematria cipher that's in tribute to Hebrew and Greek isopsephy. And understand, with all of these ciphers, you can click on it. You can click on the cipher, and then you got to come down here and click the view chart. You can see what the letter values are for the chart, you see? And, you know, there's some really cool things in English Extended. Gutenberg equals 666, the name of the first printed Bibles. 666, this biblical number. Religion, 260. There's 260 chapters in the New Testament. And a million other things. I mean, if you study these ciphers, you can see where their relevance is and why things have been coded as they are and why these ciphers have been built as such. Sumerian Gematria. What that is it's directly connected to English Ordinal. It's English Ordinal times 6. And my favorite example all time is Michael Jordan, 113678. If we type in Kobe Bryant, 113678. If we write Deer Basketball, 113678. If we write Utah Jazz, 113678. Remember, Kobe Bryant retired exactly 678 weeks after Jordan. On the nose. Jordan once retired after playing the Utah Jazz. Kobe Bryant finished his career against the Utah Jazz. Of course, Michael Jordan ended up finishing his career in Philadelphia, where Kobe's from. You know, on the same date that Kobe plays his last game, the Golden State Warriors eclipsed Michael Jordan's win record, winning their 73rd game. And Steph Curry and Klay Thompson set a new NBA record, two teammates combining for 678 three-pointers. You know? And, you know, with regards to Stephen Curry setting that record of 73 games, his birthday is Pi Day, the 73rd day of the year. You know, Curry always gets the big pie tributes. Notice his name, Stephen Curry, equals 73. This is where you want to use the exceptions. This is how you know the exceptions are relevant. The word number is also 73. Think about the number pi, how relevant it is. The year Michael Jordan set the win record at 72, you know, way before Steph Curry broke it, his 73rd game that year was against Steph Curry's father, Del Curry. You know, and I can go on and on. Kobe Bryant's father was Jelly Bean Bryant, played for the Catholic University of LaSalle in Philadelphia. Joe Jelly Bean Bryant was drafted by the Golden State Warriors 41 years before Kobe Bryant retired. You know, Kobe Bryant, 41 in reduction. Golden State, 41, that's the 13th prime. Jordan and Kobe retired 13 years apart. You know, Kobe had 2 jerseys retired, and it was at a game against the Warriors. Anyway, getting off on a tangent here, but I'm just trying to show you how all of these ciphers really are part of a related system. And when you study these ciphers, you know, you can make a lot of valuable connections. Reverse Sumerian. It is reverse ordinal times 6, you know. Dow Jones. We talked about the Dow Jones collapsing 666 points on the 33rd day of the year, February 2nd. You know, if you missed my video on that, there's a whole lot more to this riddle. But again, this is how you see that these ciphers are relevant. Jewish reduced and Jewish ordinal are ciphers that Derek has built on a theory. And I'm not going to say that these ciphers aren't true, but they're ciphers I don't use because I know that outside of the theory Derek's built, there's no other real evidence that they exist. Now, that doesn't mean that these are false, because I do see a lot of interesting things in these ciphers, such as Dow Jones being 47 and 119. Very important numbers. But what Derek's done is he's taken the Jewish cipher, which is relevant. Let me just show you this. The Jewish cipher, this is the way the Jewish cipher works. It's similar to English extended. It's also a tribute to Hebrew Gematria and Greek isopsephy. He's taken this order and he's made an alphabetic order out of this order. That's what Jewish ordinal is. You know, just making this 1 through 9, 10 through whatever it is. You know, just counting the alphabetic order with the letters in this different arrangement. You see that? And then the Jewish reduced is just using the rules of numerology on that alphabetic order. So it is intuitive. It is logical. It's possible that's a real cipher. Septenarian Chaldean. These are very relevant ciphers. If you're going to extend out of the base 4 ciphers, I would definitely recommend looking at these two. If you've seen my work on Washington, D.C., the land of 47, it's very interesting that septenary and Chaldean both equal 47 in this cipher. A lot of important connections in these two. These are cherries on the top in addition to the base 4 ciphers. So experiment with them, you'll make a lot of important finds. Satanic Gematria. Satanic Gematria equals 666 in Satanic Gematria. This cipher starts with A is 36, goes up to Z is 61. 666 is the 36th triangular number. So think about how perfect that is. The Kabbalah ciphers. They're very interesting. They're all different methods, but sometimes they have major overlap. And notice the word riddle is 74 in all of them. You know, Jim Carrey plays the Riddler in Batman and teaches the world about Gematria in that movie, just like he does in the film The Number 23. And let me see if I got this right. Is it President's Day? It is. President's Day is 187 in 2 of these ciphers. Remember, Washington, D.C., 187, George Washington, 187. Trump had his GOP convention, 18/7, 187 days before Inauguration Day. The prime cipher. It assigns a prime number in order to each of the alphabetic order. Is it United States of America? Is that what it is? Yeah, United States of America is 722. And the reason I find that so interesting about this cipher is because Lincoln, who died to save the Union, died at 7:22 in the morning. Lincoln died on a date with numerology of 84. and 102. You know, at 722. 77 is a big number in his death as well. 22 divided by 7 also gives you pi. In the Kabbalah cipher, United States of America is 314, like 3.14. Remember, just using the alphabetic order, if you write 22 divided by 7, the shorthand to get you to the approximation of pi, it equals 314, like 3.14. And if you write 360, like the degrees in a circle, 227. You see? The trigonal cipher, that's just using trigonal numbers instead of prime numbers. And the squares is using square numbers. You know, I don't use these 3 ciphers too much. As for the Hebrew ciphers, you have to go to, you know, Google and do Google Translate. So type English to Hebrew. You know, you can just type in a word here. It'll give you the Hebrew value. You copy that Hebrew value. You come to the calculator. You plug it in. You get the Gematria of love. And I'm actually kind of blown away by that. Is it really 13 in all of them? I never knew that before. So, you know, learn something new every day, truth seeker. But that wraps up this lesson. Until next time.